Welcome students. Now we are going to start a new topic, significant figure of the class 11 physics chapter units and measurement by your tutor, guider Sapna Soni. Now let's start the topic, significant figures. A significant figure is defined as the figure which is considered reasonably trustworthy in number. For example, like the value of a pi is we know 3.14 generally which we are taking, but the correct value and trustworthy value that will be 3.141592654. This is up to 10th digit and this is a 3 figures. So this is a 5 digit. If I'm just talking to you students, which is the most reliable value for a pi? Most of the give the answer the first one because that they had a 10 digit more information. So who have more information? Students, like if I'm just taking the value of a pi or root 2 like this, now there will be a numbers which is a rather than a particular digit. So those give actually more digit means that will be more significant. So the significant figure indicate the extent to which the readings are reliable. Like rules for determining the numbers of significant figures. First, all the non-zeros digits in a given number are significant without any regard to a location of the point decimal if any. For example, like 18452 has a 5 significant digit because we can easily count it. There is a no like point or decimal here, so we that all the values are significant. We have to take all these values. So the thing which we have to remember that all non-zero digit, like here there will be no zeros are present, they are significant. Okay. So we have 5 significant figure in this number. I hope you understand students. Now, if I'm taking this value, so 1845.2 or 184.52 all have same number of the significant digit, that is a 5. Because after a point this is also countable number 52. So this is also a significant number. Now the next one is what? All zeros occurring between non-zeros are digits are called as significant without any regard to locate the point decimal, if any. For example, I'm just taking 106008. As you know, this is a one non-zero digit, this is a one non-zero digit, at the last non-zero digit. In between some zeros are there. So we just count this value as a significant. Clear? So there are the 3 zeros and all 3 zeros are countable for in the case of a significant digit. So here 6 significant digits are there. Now, if I'm just taking this particular number, as you can see, between 1 and 6 there will be a 0. And after this decimal, we have a last digit non-zero, in between zeros are there. Similarly, we have first two digit are non-zero and the last one digit are non-zero, in between two zeros are there. So what we have to like train to our mind, what we have to give the command to our mind, like see the digits. If that zero will be coming in between the numbers which is a non-zero, that will be countable. As like here we have a 6 significant digit. If the number is less than 1, all zeros to the right of the decimal point, but the first non-zero digit are not significant. This point is quite important. So I just want to brief you like what is the meaning of that. For example, like this. So we have taken the number which is a less than 1, as you can see. all zeros to the right of the decimal point. So like this is a decimal and all points are here in the right side, not the left side. Okay. But the first non-zero digit are not significant. Clear? So as you can see over there, this is a zeros, this is a zeros. And from here, this non-zero digit are starting. So for that scenario, what we are saying in this example, all zeros before 3 are not significant. Means what we have to take, we just firstly search it out. Okay, 3 is a number, okay, which is significant. Which is significant. So we have to focus on the firstly significant figure. If before significant figure any zeros are coming like this, we are not counting this. But after, just take it further. अभी उसको समझेंगे. But now what we have to understand, like before non-zero digit, zeros if present, that will be not significant actually. All zeros to the right of the decimal are significant if they are not followed by non-zero digit. For example, like this. This have a 4 significant digit. Okay. So if I'm just taking, see, the first one is a what? Is a non-zero. So the thing which we have to remember, if this question is like that, so they have one significant figure. Because we just start to count from where is the non-zero digit are actually lie. Here the non-zero is firstly lie. After that zeros are countable. So what we understood actually from this scenario we understood if the non-zero digit are coming after 0. So that previously 0 we are not counting. And after the zeros, like a 3 is a non-zero, after the zeros are, before the zeros are coming, so we're not counting, and after the zeros are coming, so we are just counting and that particular things. Next, all zeros to the right of the last non-zero digit in the number having no decimal point are not significant. Like this. Now, the point which you have to remember. Here, as you can see over there, if the digit is like that, 30, this have only one significant figure. Understood, student? But if the figures are like that, so all these three are countable. So be prepared. If in between a decimal is there, so things will be countable. And if not, so no countability will be for that. So this is a one example. Now I'm just going to start few questions so that more understanding will be made. So more the number of significant figure shows more the accuracy, error, number of the figure and the values. I'm just dropping the question for you students. Yes, the correct answer for this question is a more accuracy. Who have a more significant figure shows more the accuracy for that. Next, if a measured quantity has an insignificant figure, the reliable digit in it are an, bn minus 1, c2n, tn by 2. The correct answer for this question is n. If the measured quantity has an insignificant figure, reliable digit will be for that scenario is n. Order of magnitude. So what is the order of magnitude? The order of magnitude of a physical quantity is the value of its magnitude rounded off to its nearest integral power of 10. For example, like to find the value of to find the order of magnitude 1, 2, 3 kg. So what we can write over there for that? Firstly, 1.23 10 to the power 2 kg. Means after a particular digit, if we just want to put a decimal, for that we just need again the 10 to the power something. That integral power of a 10 actually define the order of that number. So what is the meaning of that? we simply like if the values is very expandable in a form. So if we just want to write in a short way, we just use this order of magnitude terms. The number before decimal is a less than 5, hence order of magnitude 10 to the power 2 kg. If I'm just taking this 6527, for that scenario, what we are just putting 6.527 10 to the power 3. Now, the first digit which is a came is a greater than 1. So, what we are saying that exact order of magnitude is 10 to the power 4 kilometer. I hope you students understand. There will be little bit you have to like more focused on this point. If this, as you can see, this is 1 is a less than 5. For that scenario, the 10 to the power which is actually that's the order of magnitude. Okay, but in the case of a 6, this is a more than 5. For that scenario, we just add up 1 so that order of a decimal will be changed for this scenario. State the order of magnitude of duration of the day. So duration of the day, we know that is a 24 hour. 24 into 60 into 60 second we have. Or we can say that 86,400 second. In a number, we can represent as a 8.6400 10 to the power 4 second. As we saw here, like 8 is a more than 5. So the order of magnitude will be 10 to the power 5 second. I hope now it's quite easy for you students to solve this, how to solve actually order of magnitude. I hope it is it. Give the order of magnitude of mass of proton, where the mass of proton is 1.67 10 to the power minus 27 kg. So students, as you know, the mass of proton is actually given 1.67 10 to the power minus 27, and here the order of magnitude is actually 10 to the power minus 27 because this number is actually nearest, we can say equals to 1 also. So in the case of a less than to 1 and equals to 1, we just take same value for of order of magnitude. But in the case of a different case, like if I'm just taking the value of 8, 6, 5, 4 like this. So this is a greater than 1. Greater than 1. And in this scenario, what we are just taking, just simply we just put plus 1 over there. So if the number will be like this 8.67 10 to the power minus 27, and you have to find the order for that. So in this case 8.67 is a number and the order will be 10 to the power minus 26 will be there. But here we just saw that here the value of a 1 is less than actually equals to 1. So for that scenario we just put the same values. I hope you understand, student, what I am just trying to elaborate you. Next we have a rules for significant figure. All non-zero digits are significant figures. Numbers, significant figure. 1, 6. Okay, 16 there. 2. 1, 0, 1683, 4 significant figure. 16835, 5 significant figure. All zero occurring between non-zero digit are significant figures. So I'm just wanting to write this number again because there will be too much like hotspot will be there. So 16, 1683 for this 16835. These are the number. All zeros occurring between non-zero are a significant figure as we saw. Like 3, 8,000, so 4. This is a 4 with this. But here, so 5. All 0 to be right of the decimal point to the right. And non-zero digit are significant. So 2, 2, like this. I hope you're understanding like what I'm just writing and what I just want to elaborate. Students, now just give me the more I'm just want to give you the more accuracy. The power of a 10 to the power is not actually countable, so the power of a 10 are not counted as a significant digit. If the value is a 1.4, so we are taking just only for the significant value, only we are taking only two values like 1 and 4. So they have a two significant figure. We are not counting this particular values. All 0 to the right of the last non-zero digit are significant figure. Means if I'm taking a particular value which is the last of the non-zero digit are significant also, like if I'm just giving number 40. So this is, as I told you, if this will be 4.0, the significant figure will be 2 students. So here maybe confusion arises for you. So this need practice for yourself. Otherwise, the things will be very much easy in the case of significant figure. If the thing will be 40, so this will be 1. Again, 4, 1, 0, 2. Now this, try to explain. 40240. Yes, that will be 4. So as you can see for this question, this is a non-zero, this is a non-zero, and in between 0 are there. So this will be countable for that. And yes, of course, after non-zero, this will be have no value, no significance. Okay, so we are just taking the, we just eliminate this value if we just signify that. Okay, so yes, in between, if यहाँ पे 0 होता, so what we are doing, we just count 1 2 3 4 5 and 6 also. After for that, this will be have 6 significant figure. I hope you are understanding what I am trying to say, students. अगर यहाँ पर हमारे पास 0.0 अगर हम लगा देते हैं, so what we can get, we just getting the value like 1 2 3 4 5 6. They have a 6 significant figure for that scenario. So you must like think about that. थोड़ा दिमाग लगाओ और यहाँ पर अगर पॉइंट है तो उसको काउंट करो. क्लियर? नेक्स्ट, all 0 to the left of the non-zero digit are non-significant figure. Like numbers and significant figure are there. 0.08, 1. 0.008, again 1. Try to give this answer. Yes, this is a 3. So students, what we are doing here, if the non-digit here, this is a non-zero digit. So if the digits are a non-zero, as you can see, this is a non-zero. Before that, if zeros are coming, this is a not countable actually. Countable only that which is in between the non-zeros. Even the last one of the like non-zero, that also not countable. We just look this particular point. As you can see over there, we have this scenarios, and this is at the last, which we are not counting over there. So I hope you are understanding what I am trying to say. पहले आएगा, again not counting. Last में आएगा, again not counting. If there will be a desert, like a decimal will be there, then after, if after zeros are coming, that counted. Determine the number of significant figure. Numbers, this. Can you please signify it, students? Yes, the correct will be 4. For this, 4. For this, 10 to the power minus 9. Is this countable? Yes, this will be not countable. So the correct answer 3. What the scenario? Try to give the answer. 3 to 5. Now, for more accuracy, as we go through this topic significant figure, for more accuracy in ourselves, we just want to need practice. For this, MCQs are there. So the number of a significant figure in this, the correct answer will be 1. As I told you, students, like if the number is a non-zero and before that zeros are there, that will be not countable. That's why this answer is a 1. The number of a significant figure for this, we take care, like be careful for this. This is a non-zero. Before that 0 are there and after that 0 are there. So the correct answer for this question is yes, 3. Because as I told you, if the non-digit digits are there and before 0, that is a not countable. Okay, not countable. But after the zeros are countable. Now I think you understand and things will be quite easy for you. Very good. I'm also understanding like you are grabbing the things. Significant figure depends on dash, the measuring instrument, length, reading, numbers, accuracy. The correct answer is accuracy. More significant figure actually tells that how significant, how the accuracy of that particular reading have. The rounding of the numbers. Rounding off numbers, students. The process of omitting the non-zero digit and retaining only the desired number of the significant digit. Incorporating the required modification to the last significant digit are called as a rounding of the numbers. So students, in simple, if we just want to say like we have some particular significant value and that significant values describe the values with the accuracy, but all the numbers like if the quantity have a, like by the value we know the value of epsilon naught like they have a large particular digit, we can't write for the calculation this much particular digit. So that's why we have to go through the particular desired number. So for that we can get the values. Like we know the value of actually speed of a light like this. This is the speed of a light actually. But we are not taking this. We are just taking round off and this values help. We just calculated the meter per second. So what's the meaning of that? We just not in every calculation. If I just want to this value, that will be like tough to speak also and tough to calculate. But what we are doing, we just take a simple number like 3 is a very easy to multiplication or divide something else. So in the calculation 3 will be easy instead of a 2. Understood? 2 lakh, 29 lakh. Like this number is a very tough for the also for the speaking purpose and for the calculation purpose. Now, rules for rounding off like the preceding digit raised by 1 if the immediate insignificant digit to drop is a more than 5. For example, if I'm just taking 4728 is a rounding of a 3 significant figure which is a 4730. So why we are just taking 3 significant figure? Because as you can see, as a round off is nearly to 30, and we know that value like 0 is a non-countable. Non-countable. If that is like after the non-zero digit, that's why we have just saying they have a 3 significant figure. In all the above, the digit to be dropped should be less than 5. But given is a 5, so it should be any digit less than 5. For example, like 4723, round off it will be like 4723 again 20. So again they have a 3 significant figure. If the immediate insignificant digit to be dropped is 5, then there will be two different cases. The first case, if the preceding digit is even, uh, it is to be unchanged and 5 is dropped. For that scenario, like a 4.7253 is to round it off to decimal places. The digit to be dropped here is a 5 along with 3. So, and the proceeding part is a 2 is like even, and hence to retained as a 2 only, like 4.72. Now again I'm just want to elaborate is of what actually we did. As you know that like here if I'm just counting 1 2 3 4 5, okay, so preceding digit is a even. If I'm just taking like 3 is odd, then 5, then after even number is there. Okay, now and to be unchanged or and a 5 dropped. So if this will be even, we just take this value. If this will be 6, we can choose either other particular cases we saw later. So as we saw, 3 is odd, 5 is odd, then we just move on a 7 part. Now, like here is a 5 with the 3, so we're proceeding with the even number. Hence, that's why we are taking 4.72. Case 2, if the preceding digit is odd, so that will be raised 1 like this. As you can see, like 3, then 5, then again 1. So what we are just taking, as you can see, after 2 decimal places, there will be a odd digit are there. And last 5. So what we are doing, 1 as a 2. We just change this value. Rules for arithmetic operation with a significant figure. In multiplication or division, the final should retain only that many significant figure are there in the original number with the least number of significant figure. For example, 1.2 into 2.54 into 3.26, all they give 9.93648. But the result should be like limited to least number. So what we are going to do, we just saw, we have just taken 2-digit number. And as you can saw that they have a 9.93648. If I'm just taking two particular digit, for that scenario, the significant of a 2-digit only be possible for the final answer 9.9. In addition, multiplication, we just try to take like least number like 9.9. But in the case of addition and subtraction, the final result should retain only many decimal places. And there are the number at the least decimal places. I just give you the example so that more accuracy will be there. So 2.2 plus 4.08 plus 3.12 plus 6.38. This will be give 15.78. And if I just want to write up like very least digit for that, so rounded off we can just do like 57.7. Okay, for that, see students, what we are doing actually, the number is a less than like the second place number is a less than 5. Okay, so for that scenario we just take a 9.9, but here like 7, 15.7 and 8. So what is it here? 8 is a greater than, 8 is a greater than 5. That's why we raised one number for this scenario. That's why 15.8. So round off to 3 significant figure for this. If we are just taking 2, so the things will be different, and 3 significant figures, so we are just taking up to this point. Now we have to imagine and focus on this number. Is this 5 equals to 5, greater than 5, or less than 5? It depends on this value. Like 8 is what? Relate to the 5. 4.92, 4.93, 4.94, 4.91. The correct answer, you know students, this is a 4.93. Okay, as we know that 5 is less than 8, or we can say 8 is greater than 5, for that scenario, what we are doing, we just raising this value 1 in this number. Next, okay. Okay, so this is the final question, like last one is the final question. So I just try to elaborate you students little better. So what we did in the last, I just want to elaborate this particular question in a few like more way. 8 is greater than 5, so we proceeding one digit and increased by plus 1. Okay. Similarly, if the question is like that, 4.91, like 3, and the same question is there, for that question you have to again look this particular point. Is that 3 is it greater than 5 or a less than 5 or equals to 5? For that scenarios, we accordingly we did. So we are not doing minus, okay, for that scenario. We just write up as simple the values are given. So I hope you understand student. Now, at the last, thank you so much for watching this video. I hope you understand many things from this lesson, and So please be with us. And then again, group of digital learning and schools. Thank you, students.